In this video, we are going to look at straight line graphs. But before we can look at that, we need to think about formulas, because obviously there is a formula for a straight line graph. One of the first times you are introduced to formulas is when you start working with patterns, and you even do this in primary school. So if we look at this pattern over here, it will actually help us to understand what is happening with a straight line graph formula. You might know that if we work with a pattern like this, we can have a look at what stays the same and what is added in each pattern. So in this specific case, one stays the same, and then every time I add 5. So if I have to color code it, it would look like this. And you might also know that if I had to write a formula, remember that this is pattern 1, pattern 2, pattern 3. So I know that in pattern 4, I will have one match plus, and because every time I added on 5, and here we have 2 5s, and here we have 3 5s, in my next one, I will have 4 5s. So if I calculate this, it will give me 21. Writing a formula for this will look like this, and you can write it in two ways depending on how you like to order things. So you can either say 5n plus 1, or you can say 1 plus 5n. And it's 5n because every time I multiply the pattern number by 5. Now my straight line formula looks the same, and your teacher might have also mentioned that this is linear patterns when you did this, because it refers to kind of the straight line formula. In my straight line formula, my general formula looks like this. I have a y and I have an x, because remember that when I draw a graph, and you might be familiar with the Cartesian plane, which is the fancy word for this grid paper, that I have an x-axis and a y-axis. So we are showing the relationship between x and y. We write it as y equals to mx plus c. Can you see how this looks the same? C is also our constant value, and m refers to the growth or the gradient. So our growth for our pattern was 5 here, and this m also refers to the growth on the graph. We will look at exactly how to do this, but if I can quickly show you on a graph, that would be my constant at 1, and the growth will be for every 1 across, it will go 1, 2, 3, 4, 5 up, and my graph will look like that. However, let's first look at the Cartesian plane before we jump ahead and start drawing graphs. For now, it's important that you understand that linear patterns have the same structure of the equation than linear graphs. So let's have a look at the Cartesian plane. Hopefully you know that this is the x-axis and this is the y-axis. So here we have a graph that is drawn, and you will see these two important words that you need to know. The x-intercept, which means where the line cuts the x-axis, and the y-intercept, where the line cuts the y-axis. We can also write a set of coordinates, and remember that when we write coordinates, we always write the x-coordinate first. So at the y-intercept, my x-coordinate will always be 0, and my y-coordinate will be wherever it cuts the y-axis. Similarly, for my x-intercept, my y value will be 0, because remember this point here is 0, it's on the line, and my x value will be wherever it cuts the x-axis. This is actually a very important concept, because if you understand this, you can calculate, and by substituting 0 into your formula, where a line will cut either the x-axis or the y-axis. Let's use what we've just learned about the x-intercept and the y-intercept to see if we can draw each of the following straight lines. Can you see that the first one looks like your pattern formula, your linear pattern formula, where we had Tn equals the difference times the term number plus the constant? Okay, we're going to do the same here. So if we make this our red one, let's start by calculating the y-intercept. In order to calculate the y-intercept, I need to make x equals 0. So y equals to 2 times 0 plus 4. Just like with patterns where you could substitute any number into n, we are doing the same here in order to find a value. So if you understand substitution, this should be really easy for you. Okay, so back to our calculation. 2 times 0 plus 4, and that gives me a y value of 4. And I can go and make that dot on my graph because that is my y-intercept. Now let's calculate my x-intercept, and this is where y equals to 0. So 0 equals 2x plus 4, which I can also write as negative 2x equals 4. And then I can divide by negative 2 on both sides, which gives me negative 2. And I can go and make a dot at negative 2 on my graph. Now, in order to draw this line, I can connect both dots with your ruler, making sure that you accurately go through both points. And it's also important to extend your graph, so in both directions. So in order to do that, we put an arrow at the end of each line. Okay, so let's also have a look at how to do the next one. The next one is not in standard notation, but it doesn't matter because I would just like to know what my x and y intercepts are. So once again, I'm going to substitute this into my graph. So if we write it over here, I can say to find my y-intercept, I'm going to make x equal to 0. So 5 times 0 plus 4y equals to 12. That's really easy because it just means that 4y is 12 and therefore y equals 3. So I go and make my dot on my graph where y is 3, and I do the same for the x-intercept. X-intercept is where y is equal to 0. So let's just move everything up so I have a bit more space. So that means I'm going to have 5x plus 4 times 0 equals 12. So if 5x equals 12, then x equals 12 divided by 5, and that gives me 2.4. Not such a nice number to plot, but not entirely impossible. So I'm also just going to write here that this is 2.4. So you will see that this graph is now going to go in the opposite direction from the previous one. So using your ruler, make sure to connect both those lines. For you, it's a little bit easier with your ruler than it is for me to move my line. So make sure that it's exactly on those dots and that you make an arrowhead on both sides. Every time you need to draw a straight line graph, it's important that you show the intercepts with the axes. So here it was 3 and 2.4, and for the other graph it was 4 and negative 2. You could also be asked to write the coordinates of those points, and then you will have to say negative 2 and 0. And for this one, remember that your x value is 0 at the y-intercept. And the same for my blue line, that would be 0 and 3. And this one would be 2.4 and 0. It's also good to put your curly brackets around all of them. So hopefully it's now clear how you can find the intercepts with the axes by substituting 0 into my formula. So x equal to 0 for the y-intercept and y equal to 0 for the x-intercept. In the previous example, you would have seen that the one line seems to go up and the other one seems to go down. This has to do with the gradient. Just like with the patterns, it means that there is either a growth, that the pattern gets bigger, or you might have also worked with patterns that get smaller, where you have a negative value, that is the growth. So think of those patterns where you have to multiply a negative number by n and then add or subtract the constant. So I really like running, and I find that this is a good way of thinking about gradient. So often when you go and run a race, you get a profile map at this, like this one here. This tells you when you are running uphill and when you are running downhill. In this example here, you can see that the race starts with an uphill. Okay, so this is called a positive gradient, even though you might not be feeling very positive when you're running uphill. And over here we have a negative gradient. This one is going down. So when you have a coefficient of x, just like you would have a coefficient of n when we did patterns, that coefficient of the variable tells you whether your growth is positive or negative. You could also have a zero gradient where you are not going up or down, but it's just horizontal. So we are also going to look at that. But for now, it's important that you understand that you can have a positive increasing gradient, that you can have a zero gradient where it's flat, just a horizontal line, and a negative gradient when you go down. Let's have a look at what this looks like in the following example. Here you can see that I have a positive gradient and I have a negative gradient, but let's see if we can find the value of each one. You will see that in each case, a set of coordinates were given, and we can label them as the x1 coordinate and the x2 coordinate, and the y1 coordinate and the y2 coordinates. And I've done that for each example. I will show you why that is important in terms of the formula, but let's explore what is happening here. So on the left-hand side, with my positive gradients, and we can even make a note there for ourselves that say that this is my positive gradients, just as a reminder. Now let's see, how many did I go this way and how many did I go up? So if we count, it's going to be 1, 2, 3, 4 in this direction. And if I count how many up, remember I go from -2 to 6, so you already know that that is 8 up. Let's write this down. So my letter or symbol that I use for gradient is M. So I'm going to write for every 4 across, it goes 8 up. We know it's positive, so therefore I know that it's a positive gradient. So 8 over 4 simplifies to 2. Let's see what happens with the gradient on the right-hand side. We know that this is a negative gradient, so there must be a negative value that I calculate here. So if we have a look from 4 down to -2, that must be 6 down. 1, 2, 3, 4, 5, 6 down. So do it like that. Because it's down, we put a negative sign. And from -3 to 3, that should be 6 horizontally. Yes, that is. So that means that this gradient is -1. Remember to always go from left to right, like I've done here. Just remember, we always read from left to right. And the same thing with our graphs. We know that this is increasing because if I read from the left to the right, the lower point goes to the higher point. Therefore, I know it's an increase. And here, the higher point goes to the lower points if I read from left to right. So always remember left to right. I did refer earlier to the y1 and y2, and you might wonder why it's written there. This is to remind you that we have a formula which we can use. So with the formula, I can subtract my two y values and I can subtract my two x values in order to find my gradient. Just be careful when you do this that negative does not confuse you, because we often make mistake with our negative numbers. So in my first example, I can take the y value of 6 and I can subtract the y value of -2. You know that this gives me 8, and then I can take 2 and I can subtract the value of -2, and this gives me 4, and you will see that I get exactly the same answer. Let's also use the formula for the negative gradient. So here I can say 4 subtract -2, so that will give you 6. And here I will have -3, and I subtract 3, and that gives you -6. Remember that it doesn't matter where the negative is. When you simplify this fraction, it still gives you -1. We've covered a lot of different ideas now, so let's see if we can put them together and draw some graphs. This first one looks rather strange. It only has a y value, but you might know that this means that it has a 0 gradient, because 0x plus 5 is the same as saying y equals to 5. Do you still remember what a 0 gradient looks like? Yes, it's like just walking flat. So always start by making a dot where y is equal to 5. You know it's a flat gradient, and this also means that y is just always 5. It doesn't increase, it doesn't decrease, y is just always 5. So we have a horizontal line like that. Now, we haven't spoken about the next example yet, and this is the one where x equals to -3. So I go and make a dot where x is -3. Just like with a y equals to 5, where y is just 5 all the time, it doesn't increase or decrease, here it means that x is always just -3. But this looks a little bit strange, and you're never going to see this on a profile map of a run that you do. Because if you do, you'd be falling down a cliff. This is a reminder that this gradient is undefined. Undefined. You will do more of this in grade 10, where we consider what a function is and what is not a function. But for now, just know that this is undefined. So the gradient is undefined, where in the yellow line, this gradient was equal to 0. Okay, now let's have a look at the other other 4 formulas that they've given us and how we can draw this graph. So in my C formula here, if I make x equal to 0, you should now know that this whole thing is going to be 0, therefore y equals 6. So whatever value you see in the straight line formula, at the end as your constant, that is going to be your y-intercept. Okay, but remember, if you're not sure, always just substitute x in as 0 in order to find your y-intercept. Okay, but it's very easy to see in this case that it is 6. Now, what is this here? What does this mean? It means for every 5 across, this graph goes 3 down. So if you want to use this gradient method, it will look like this. From 6, which is my first point, I'm going to go 5 across. 1, 2, 3, 4, 5 across. And 1, 2, 3 down. I'm going to make a dot. You can even do this another time. You can say 1, 2, 3, 4, 5 across. And 1, 2, 3 down. And I happen to find my x-intercept. We will, however, calculate that just to be sure. And now you can connect all these dots in order to draw your straight line. Hey, so if you were not sure about that gradient method, let's see if we can go and calculate this point over here, which is my x-intercept. And remember, in order to do that, I make y equal to 0. So I'm going to have 0 equal to negative 3 over 5x plus 6. I can also write this as 3/5 x equals 6. And if I go and divide 6 on my calculator by 3/5, remember it might seem funny, but on your calculator it's really easy. You get a value of 10. So that's how I can also calculate that value in case the gradient method was a little bit confusing to you. Let's also have a look at the next one, at D. So here, once again, if I make x equal to 0, I can see that my y value equals 5. That is my y-intercept. And I can go and plot that first point on the graph because I know it cuts my y-axis at negative 5. In this case, for every 3 across, it goes 5 up. So let's do the gradient method as well. 1, 2, 3 across, and 1, 2, 3, 4, 5 up. Once again, purely by chance, I've hit my x-intercept, but we will also go and calculate that point. Remember, whenever you need to draw a graph, you just need 2 points. So that really helps. Let's see if we can calculate this x-intercept. So remember, once again, I make y equal to 0 equals to 5 over 3 x minus 5. So I'm going to take the 5 over in order to keep things positive. And when I say 5 divided by 5 over 3, I get a value of 3, which is x. So that's how we could have calculated that x-intercept point. Hey, we have 2 lines left over to draw. So let's have a look at the next example. By now you should know that the negative 2 is my y-intercept. So I go and make a dot there. This has the same gradient for every 3 across. It goes 5 up. 1, 2, 3 across. 1, 2, 3, 4, 5 up. Now I have 2 points and I can go and connect them. So hopefully you notice that the purple line and the blue line are parallel. The reason that they are parallel is because they have the same gradient. So if their growth is the same and they have the same gradient, it means that they will never touch because they go up at the same rate. So parallel, same gradients. That is very important. In the case of E, it's quite tricky to see what my x-intercept there is there. So let's just calculate this. 0 equals 5 over 3x minus 2. I'm going to take my 2 over in order to make it positive. 2 equals 5 over 3x. And if I say 2 divided by 5 over 3 on my calculator, I get 1.2 as my x value. So this value over here is 1.2. Remember, it's very important that you always show your intercepts with your axes when you draw graphs. Hey, let's go over to our last line, which is F. So F, we can see that my y-intercept is positive 4 because I make my x equal to 0. In this case, it also feels like I've seen this gradient before. For every 5 across, it goes 3 down. 1, 2, 3, 4, 5 across. 1, 2, 3 down. So my second dot is going to be over there. And I can go and connect these lines. Mine is a little bit skewed, so let's adjust that. There we go. And you'll see that this one is also parallel to the red one because their gradients are the same. I can see I have a funny x-intercept here, which is going to be a fraction. So let's see if we can go and calculate that point. Let's just calculate it over here where I have f. So 0 equals negative 3 over 5x plus 4, which means that 3/5 x equals 4. If I now going to divide 4 by my coefficient of 3 over 5, I get a value of 6.67, which I can go and write in on my graph. Very full graph, but we've actually covered quite a substantial bit of content. The last thing that is important to know is how to find the equation from the given graphs. So by now you should know that my straight line formula is y equals to mx plus c. So this is called the gradient intercept form because that c refers to my y-intercept, and this is my growth, my how many across and how many up or down. Looking at A, which is my green line, let's see what is happening on my graph. The easiest thing to see, and the first thing I always look for, is the y-intercept. So I know that in this case it is negative 3. Now I need to find out how many across and how many up. So in this case, for every one across, now be careful here, even though there are two lines, it goes from 0 to 1 over here. That's 1 across. It goes up 1, 2. So 1 across, 2 up. My y-intercept is negative 3. So if I had to write this down, it would be y equals to 1 across, 2 up, x plus, no, it's minus 3 because it's negative 3. So we can write that a little bit neater as 2x minus 3. Let's see if we can do the same thing for b. In b, I see that my y-intercept is positive 3. For every 1 across, it goes 2 down, which means that my gradient is going to be 1 across, 2 down means that it's negative x plus 3. Writing this a little bit neater, it will be negative 2x plus 3. Hopefully you still remember what a horizontal line is. That has a 0 gradient and it only has a y value, which means that C is y equals to 2. Let's look at D, which is my gray line. In the gray line, you will see that my y-intercept is 0. Okay, let's see what my gradient is. For every 1 across, it goes 2 up. And it is also parallel to my green line, which means they will have the same gradient. Therefore, D's formula will be y equals to 2x plus 0, but obviously I do not have to write that. E is my light blue line, so let's go and see what's happening there. My y-intercept is negative 2, and then for every 1 across, it goes a half up. Ooh, that is strange. Let's write that down. So for E, it is y equals, for every 1 across, it goes a half up, x, and my y-intercept is negative 2. If I write that a little bit nicer, a half over 1 is just a half. So that means for every 2 across, it goes 1 up. Let's just check. For every 2 across goes 1 up. Yes, that is true. Minus 2. Hey, our last line is our black line, and I can already see that that has a negative gradient with a y-intercept of 2. Now we have a look. This also looks like a half. So let's see what happens if I go 2 across. 2 across goes 1 down. So this one for f is y equals, for every 2 across, it goes 1 down, so that's negative a half x, and my y-intercept is positive 2. I hope by now you know the basic formula for a straight line of y equals mx plus c. You know how to calculate your x and y intercepts. You know how to work with gradients, and you understand something about parallel lines.